We're looking at Pythagoras' theorem again for the second time, and in this video we're finding the shorter side instead of the hypotenuse. We're going to start by looking at some cranes, and cranes are very important. They do an important job, but safety is really important with a crane. We can find certain distances of a crane if we know certain other dimensions. If we see this crane here, that's something's gone wrong there with their estimation and it's fallen over. It's been a pretty nasty accident. Before we look at some of the lengths, we might notice that there's a certain type of triangle present in this situation, and that is a right angled triangle. And we can see that in this case here, it appears that the weight or the length with that given weight was too much, and it's made the leverage, which has turned this crane over on its side. On this other crane, which hasn't fallen over, we can draw a right angled triangle too. Like so. It's a bit rough, but you get the idea. So we have a right angle here, even though mine's not very neatly drawn. And we've got the main arm, or the jib, forming the hypotenuse. Let's say we needed to find this height here, which I'm going to call A. Let's say we needed to find that in order to, for a given weight, we needed to be able to lift that height, or at least get the top of the crane to that height so we can deliver something at a certain height. If we were looking for A, and let's say we knew that the length of the jib was 50 meters, and they knew that this dimension on the vehicle out to the bottom of the jib was 30 meters. That's probably not realistic. Just keeping the numbers nice and easy, but we could work out the height using Pythagoras' theorem. We know from our previous work that the hypotenuse C, once we square that, we get C squared. C squared equals A squared plus B squared. We looked at that in the last two videos. We've practiced some questions in class finding C squared. If we try and substitute in the same way, we're actually already given the value of the hypotenuse. So C would be 50, therefore C squared would be 50 squared. But we don't have A, so we still have to write in A squared. But we do have B. If we say this one's B, B's 30, so therefore B squared would be 30 squared. But this is where the question differs. We would be adding the two squared values together, then take the square root as the last step in the previous type of question where we're finding the hypotenuse. But this one, where we're finding the shorter side, we have to do something different. To get A squared by itself and then A by itself, we first must subtract what's attached to it, and if we look at what's attached to it, it's this number here, 30 squared. 30 squared is just a number, 900. So we need to subtract that off both sides, because what you have to do with one side of an equals, you have to do to the other for them to stay equals. So to get A squared by itself, we have to minus 30 squared off both sides. That's what we do. We subtract 30 squared off both sides, and it's still equal. If we subtract 30 squared off the right hand side, that 30 squared you see there will go. It'll be 30 squared take 30 squared, which is 0. But we have to do it to the left hand side as well. So what we have is A squared will be by itself, and I'm also going to put A on the left because it's the result we're looking for. A squared equals 50 squared take 30 squared. When we calculate the values, we have 2500 minus 900, which comes out as 1600. Now remember to write a squared there at that line, because that's not our final result. We need to find a. A is the square root of 1600, which is 40. So it's 40 meters, that height. So we can see that when we've got a short side, we have to use subtraction. In summary, what we have is here in this purple rectangle, for shorter sides, a squared equals c squared minus b squared, or if you're after shorter side b, b squared equals c squared minus b squared. Sorry, that should be a squared. There we go, I fixed that up there. So we subtract a shorter side squared from c squared, the hypotenuse squared, to get through to find the shorter sides. But you can just always start these questions, even if it's whether it's the hypotenuse or the long side, you still start it the same way. You write down Pythagoras' theorem, and you just need to use inverse operations, like here on both sides. To undo a plus, we have to subtract. One last example. Example 2, find the length of x. So we can see x. We can see it's a right angle triangle and it's a side length, so it'd be pretty reasonable to write down Pythagoras' theorem. C squared equals a squared plus b squared. However, we've got a few things we need to think about. Do we have c, the hypotenuse? Well, the hypotenuse is the longest side and it's opposite the right angle. So yes, we have that. So c is 3. We don't have a and we don't have b. In fact, we got no symbols like that. We've got an x, so let's change that a to an x, and that'll be the one we look for. Then we don't have a symbol at all for this other one. In fact, we got two things that are unknown. How do we do this? Well, we look a bit more closely at those symbols there. They mean that those two lines are the same length. So what we have, instead of c squared equals a squared plus b squared, we have c squared equals x squared plus, well, if those two there are the same, they're both x, aren't they? So we have x squared plus another x squared. So c squared equals x squared plus x squared, which is 2x squared. We know that c squared is 3 squared, which is 9. So 9 equals 2x squared. Divide both sides by 2. Alright, what you do to the left, you've got to do to the right. So dividing by 2, that'll be 4.5 equals x squared. So x, you need to take the square root of both sides. I might put it in decimal form. Square root of 4.5, 2.12 after we take the square root. Whatever the units are, you should write them in if they're given. Okay, so if they're meters, write in meters and so on. So that one was a bit more difficult. Now try and find the shorter side.